Ever wondered how artificial intelligence, or AI, is reshaping the aerospace industry, particularly in the case of SpaceX? Let's embark on an enlightening journey to explore this fascinating topic. Our first stop is at the launch pad. Here, AI is far from a bystander. It plays a crucial role in managing the multifaceted process of rocket launch. From weather modeling for optimal launch conditions, to adjusting fuel mixture ratios and conducting system checks, AI is the silent maestro conducting this intricate symphony of processes. By analyzing real-time data and making split-second decisions, AI streamlines the process, potentially reducing errors and ensuring a successful liftoff. As our rocket ascends, AI takes the wheel, navigating the spacecraft through the unpredictable expanse of space. Atmospheric drag, gravity, and space debris are just a few of the challenges that AI handles with grace, adjusting the rocket's course in real time. With its superior speed and precision, AI optimizes the trajectory, balancing speed and energy efficiency. Our next point of interest is stage separation. Once the rocket has reached a certain altitude, it separates into stages, another process managed by AI. The intelligent system calculates the optimal point for this separation, considering variables like speed and altitude. And the job doesn't end there. If the lower stage is designed to be reusable, like SpaceX's Falcon 9 boosters, AI guides it back to Earth. Now, imagine a rocket booster landing itself back on Earth, or a drone ship. This is no longer a figment of science fiction, but a reality made possible by AI. Machine learning algorithms, trained on past landings, control the descent and landing of these reusable rocket boosters. They make real-time adjustments, managing the grid fins and thrusters to ensure a safe and precise landing. AI also serves as a diligent communication officer. It ensures seamless data transmission between the rocket, ground control, and satellites. Given the time-critical nature of space missions, AI prioritizes data packets, ensuring that the most vital information gets transmitted first. Maintenance, too, falls within AI's domain. By analyzing telemetry data, AI can predict when parts might need replacement or could fail. This predictive maintenance increases the lifespan of rockets and reduces the risks associated with mechanical failure. Looking ahead, the role of AI in the aerospace industry is set to amplify. Future SpaceX missions, including potential Mars missions, could see more autonomous decision-making algorithms. This would make space missions more resilient to unexpected challenges. However, with great power comes great responsibility. The integration of AI in aerospace brings along a plethora of ethical and safety implications. The industry must address these concerns proactively to ensure the safe and responsible use of AI. In summary, AI's role in the aerospace industry is both significant and multifaceted. From launch to landing, communication to maintenance, AI is the unseen force propelling the industry to new heights. As we look to the future, the influence of AI is only set to increase, promising exciting developments in the world of aerospace.